Okay, so we get back to part 2 then. We're talking about our groups. When we look at our second molecule then, our second molecule is going to be able to have on it the molecule we're going to form, in other words. It's going to be based upon what's already on the ring. So I'm going to keep referring back to these. I'm going to go back to the vanilla. We're going to look at this molecule. So we just kind of look at it close up. We can see that this is an OH. This is a C double bond OH group. Come over here and we'll try to find this in our list. C double bond OH group is a meta-directing group. So if we went back to this molecule, meta to this is at this position. Well, there's already something there, so it can't go there. So this would drive it to this position. So based upon this constituent, it should go here. Now, based on this constituent, OH is a, we'll come up here, OH is a ortho-para director. So let's go ortho to this. Ooh, ortho to this is that same position where this was going to send it meta. Ortho to this is something there blocking it, so that won't work. And now we'll look at OCH3. If we come back to our list, we see that OCH3, got to find it on our list, OR is OCH3. So it's a ortho-para directing group. So let's go ortho to this, ortho here, something there already. Ortho here, it could go here. And para to it is over here. So this one could drive it here or here. This one can only drive it here. This one can only drive it something there, something here, something here. So two of our constituents want to drive it to this position. And one of our constituents wants to drive it to either this position or this position. So the $59 question is, now the sheet I'm going to give you is going to give you a rating of the most activating to the least activating and the most deactivating to the least deactivating. And you'll have to make the judgment and the decision based upon that. You can do that in your hypothesis or in your opening statement of where you think it's going to go. And then we'll do the experiment. An experiment's not real difficult to do. Got a couple calculations you have to make. You need to make a calculation of what 10 millimoles of vanillin is. And very simply, you're going to mix that with acetic acid, straight acetic acid, in an Erlenmeyer flask, and then you're going to add the potassium bromate, that's the KBrO3. Then you're going to add the hydrobromic acid. It is very caustic. Make sure you have the gloves on for that. Stir it for about 45 minutes. So you'll have about 45 minutes. You can take the quiz then. Real simply then, all you do is dump it into an Erlenmeyer flask that has some ice cold water in it. Make a water bath and use distilled water and get it ice cold, and then stir it for 15 to 24 minutes, 15 to 20 more minutes. If it's orange colored, add some sodium thiosulfate until it turns yellow. You should get a product at that point, vacuum filter it, and then recrystallize it from 50-50 ethanol and water. Put it in a desiccator till the following week, and then we'll do melting points on it that following week. So pretty easy lab to open up the year with, but I think you'll enjoy it. Plus it'll let you see if your prediction is correct here. See ya Thursday.